Okay, looking at our part 3 of this series, volume. So this is where we're going to go through the volume rules and we'll look at the unit conversions as well. So when we're converting our volume rules, we do need to remember, like we did with the other one, when we're going from smaller to bigger, we're dividing. And from bigger to smaller, we are multiplying. And then we are remembering that if we were going from millimeters to centimeters, we would be dividing by 10, but we're going to do 10 cubed. The same as if we were going centimeters to meters, it would be 100, but we've got to do 100 cubed. And then here we've got 1,000 cubed. So when I go through an example here, I'll show you how to do that. And the same with the multiplying. So 10 cubed, 100 cubed, and 1,000 cubed up here. So just remembering to do that. I've also put a little conversion here if we are asked about capacity, where we want it in milliliters or liters. So 1 milliliter is equal to 1 centimeter cubed. 1 kiloliter is 1 meter cubed, and 1 kiloliter is 1,000 liters. So if you're having to go from meters cubed to liters, you are timesing by 1,000 to get to that. So we've got a little conversion here, 10,000 millimeters cubed to centimeters cubed. So I look up to my diagram, so going from millimeters cubed to centimeters cubed, I'm going to have to divide by 10 cubed. So that's going to be the same as dividing by 1,000. So if I've got 10,000 there, 10,000 divided by 1,000 is going to equal 10 centimeters cubed. When we're doing our volume, our general rule for volume is area of base times height. So if we can work out the area of the base, so this is for our prisms and cylinders this will work for, and we work out area of the base times by the height. Remember, the base though has to be the shape that goes the whole way through your solid shape that you're trying to work out the volume for. We do have some common rules that you might have seen. So for a box, we have our volume is equal to length times width times height. For our cylinder, our volume is equal to pi r squared times height. But if it's not a regular one, then you can work out the area of the shape that you have as your base and multiply it by the height. I've got a couple of examples here, and one in particular is where it isn't a box and it's not a cylinder. So in this case, we have a triangle base because that is the shape that goes through that whole 3D shape there. If you cut it along that line, you would get the same face that you would see, that triangle. So we need to work out the area of that, and our triangle area is 1/2 of base times height. So we've got to do 1/2 times 3 times 2.6. I used the same picture from the video in part 2 when we did the surface area of this. So when we work out the area of that base, we're going to get 1/2 times 3 times 2.6, and we get 3.9. which we found when we were working out those areas in the previous video too, but this time we have, we're going to work out the volume with it. So we've got our area there. So then our volume is going to be our area of base times height. We know our area of the base is the 3.9. We're going to multiply that by the height of the shape, which is that 11 there. And so we'll do that times 11, and we get 42.9. We've got meters, and because it is volume, we have cubed, so meters cubed. So 3D shape to the power of 3 as a little reminder there. Our cylinder one, we have our common rule for that. So that's the pi r squared times height. And so we have got pi times our radius here is 5, so 5 squared times 20. Now this is the same cylinder from part 2 as well. So you can see the difference between the surface area and the volume for that. So we've got pi times 5 squared times 20, pi r squared times 20, and that gives us our 500 pi, which we'll convert to a decimal, is 1570. And we've got 0.796, so I'm going to round that to 0.8, and that will be meters cubed. So hopefully that helped you with your area, surface area, and volume. Remember, the key part to helping you out the best with an exam on this kind of thing is knowing your all your area rules, knowing your general volume rules, surface area rules, and have practiced those questions.